Explain the video goal and say this will cover the basic concepts and steps to establish a network connection, differences between wired and wireless links, IP addressing and routing basics, common services like DHCP and DNS, security considerations, and simple troubleshooting and testing tools. Give a simple definition of a network connection as the logical and physical link that allows two or more devices to exchange data using agreed protocols and addressing. Introduce the physical layer concept in plain terms. Describe common media, twisted pair copper, Ethernet, fiber optic cable, and wireless radio, Wi-Fi, cellular. Mention connectors and cable categories, for example Cat5e/Cat6, conceptually and the idea of link speed negotiation between devices. Explain the link and data link ideas simply. Describe network interfaces, wired NICs and wireless adapters, MAC addresses as local hardware identifiers, and switches as devices that forward frames within a local network. Introduce VLANs conceptually as logical network partitions. Cover IP addressing and subnetting at a high level. Explain IP4 and IP6 as address families, what an IP address represents, the role of a subnet mask or CIDR prefix to define the local network, and the concept of a default gateway for traffic leaving the local subnet. Describe how devices usually obtain addresses. Explain DHCP conceptually as a service that assigns IP, gateway, and DNS automatically, in contrast with static addressing where values are set by an admin. Mention lease duration and renewal in simple terms. Explain name resolution and DNS simply. Describe how human-friendly names are resolved to IP addresses by DNS servers and the role of local caches and public resolvers. Introduce routing and the role of routers. Explain how routers forward packets between different networks based on routing tables and how home gateways combine router, switch, and NAT functions. Cover NAT and port translation conceptually. Explain that NAT allows private addresses to share a public IP for outbound traffic, and that port forwarding maps inbound traffic to internal hosts when needed. Describe wireless specifics conceptually. Explain SSIDs, encryption modes, WPA2/WPA3, signal strength and channels, the importance of correct password and AP placement, and that roaming between access points is managed by the client and network. Talk about higher-level protocols briefly. Explain the difference between TCP, reliable, connection-oriented, and UDP, connectionless, low latency, and give examples of services that use each. Mention common ports and services conceptually, web, email, file sharing, without listing exhaustive port numbers. Cover secure connections and VPNs at a high level. Explain encryption for Wi-Fi and TLS for web traffic, and describe VPNs as tunnels that protect data and make a remote device appear to be on a different network. Include basic troubleshooting and testing tools conceptually. Describe tools and tests such as link lights and cable checks for physical layer, IP configuration checks, ping for reachability, tracer route for path discovery, DNS lookup tests, and basic log and performance monitoring. Emphasize understanding where a problem sits, physical, link, IP routing, or application layer. Explain common configuration and performance issues in plain language. Examples: incorrect IP or subnet, double NAT, DHCP conflicts, weak Wi-Fi signal or interference, outdated drivers or firmware, overloaded links, and misconfigured firewall rules. Talk about security best practices simply. Use strong, unique Wi-Fi passwords and up-to-date encryption. Keep firmware and drivers updated. Disable unnecessary services. Segment networks for guests and IoT devices. Enable router firewall and logging, and use multi-factor authentication for remote access. Describe scaling and managed networks conceptually. Explain how business networks use managed switches, centralized Wi-Fi controllers, VLANs, and enterprise DHCP/DNS and authentication, radius/802.1x, for larger deployments and better policy control. Suggest safe learning paths and resources. Recommend networking fundamentals courses, vendor documentation and certification tracks, such as vendor entry-level certs, online labs and simulators to practice addressing and routing, and reputable books on TCP/IP and networking. Summarize the key ideas. A network connection requires a working physical link, a configured network interface with a valid IP and gateway, main resolution to reach services, and proper routing and security controls. Emphasize testing methodically from cable and link lights up to application services. Visual suggestions for the video input show animated flow from device to switch to router to internet with labeled frames and IP addresses. Show side-by-side visuals of wired Ethernet and Wi-Fi with signal strength. Overlays show simple subnet graphics and an animation of DHCP assigning an IP and DNS. Show a tracer route path animation and a ping result overlay for troubleshooting. Show icons for TCP versus UDP and a VPN tunnel illustration with padlock overlay. End with a call to action to study networking labs, use safe test environments, and practice troubleshooting step by step. Use this full script as the video input for Pictory.ai to generate an educational explainer about how to make and troubleshoot a network connection.